Orbital Drift is a game about orbital mechanics, resource management, and surviving in space. But when you start building a game like this, the user interface grows very quickly. At first, it's simple, a few panels, some basic ship information, maybe a fuel bar, but then more systems start appearing: resource systems, orbital transfers, docking, inventory, crafting, time controls, notification. And suddenly you realize the UI is no longer just an addition, it becomes a huge part of the game. In Orbital Drift, we decided to approach this problem properly right from the start. Instead of building the UI panel by panel, we built a system that lets us assemble those panels like building blocks. And today we want to show you a bit of how that works. If you're building a system-driven game, and Orbital Drift definitely is one, the UI quickly starts to look like the control center of a spacecraft. You have data about resources, orbital trajectories, ship status. You have items in your inventory, crafting recipes, and a running time simulation. All of this information needs to be displayed somewhere. The worst thing you can do in that simulation is build UI in chaotic way, because then every new feature means rewriting half of the interface. And we wanted the exact opposite. We wanted a system where you add a new mechanic and the UI simply starts supporting it. That's why the Orbital Drift interface is built around an MVVM architecture. It sounds intimidating, but the idea is actually very simple. MVVM stands for Model, View, View, Model. Gameplay systems produce data, the UI simply displays it, and between them there is a middle layer that translates one into the other. In simplified terms, it works like this. Game systems, things like the resource system, the orbital transfer system, inventory, crafting, send out information whenever something changes. That information goes to view models, and the view model exposes the data in a format that the UI can easily display. For example, number, percentage, icons, text. Because of that, the UI doesn't need to understand how the gameplay mechanics works. It just shows the result. The biggest advantage of this approach is that everything becomes very modular. Let's say we have a resource system. The exact same system can power the ship panel, an object panel in space, the crafting panel, or the inventory panel. The UI doesn't need to know where data actually comes from. It simply binds the data to specific fields, displays it, and that's it. That means if we want to show resources somewhere new, often all we need to do is create a new widget and connect it to existing view model. No new logic required. Under the hood, every major system in Orbital Drift works as a separate component. For example, the resource system, the orbital transfer system, the inventory system, the crafting system, each of them follows one very important rule. They know nothing about the UI. They don't know whether anyone is displaying their data. They simply manage their part of the simulation, and whenever something changes, they broadcast an event. For example, a resource changed, an orbital transfer started, a transfer finished, crafting started, or crafting finished. That means gameplay logic and the user interface are completely separated. Let's take a simple example. Resources. In Orbital Drift, resources are everywhere. Ships have resources, stations have resources, objects in space can have resources. Crafting consume resources, orbital transfer consume fuel. So we build a single universal resource component. It stores information about resource quantity, changes over time, consumption, production, and it broadcasts an event whenever something changes. The view model receives that information and converts it into data ready for display. For example, number of units, color, icon, change rate. Thanks to that, UI can display resources in many different places, while still using the same system underneath. Another thing that helps a lot is how we describe resources. Instead of hard coding everything, we use data tables. Each resource has an entry in a table that defines its name, its icon, its color, and how it should be displayed. Adding a new resource to the game often means simply adding a new row to the table. No code changes required. And in the future, this approach could also make things easier for modding. Another thing that makes a big difference in UI systems is how updates are handled. In a space simulation, many things can change at the same time. For example, when an orbital transfer finishes, the docking state changes, the selected objects might change, bookmarks update, the ship action state changes. If the UI reacted to every one of those changes separately, it could end up updating multiple times in a single frame. So in some places we use a batching system. We collect multiple changes together and then update the UI in a single step. This makes the interface more stable and more efficient. The biggest benefit of this architecture only becomes visible over time. When systems start connecting with each other, for example, the crafting panel came together very quickly because the inventory system was already built. A new resource panel somewhere else in the game, often it's just a single binding in the editor. Sometimes new features appear almost as a side effect of systems that are already well designed, and that's exactly what we wanted to achieve. Not implementing every feature from scratch, but assembling them from existing building blocks. Of course, the system is still evolving. Some parts will probably get simplified, some things will definitely be refactored along the way, but even now it's clear that this architecture speeds up development a lot. And in projects like Orbital Drift, where orbital mechanics, simulation and ship management all come together, good UI isn't just a convenience, it's core part of the gameplay itself. That's it for today. Leave a like if you enjoy the video. If you don't want to miss future DevNews updates, make sure to subscribe. We also recently released our first pre-alpha gameplay footage, so if you haven't seen it yet, check it out here. And see you in the next DevNews.